Hi, this is auxiliary help for your Chapter 6 in Jacobs as we get through homeworks and head into the midterms here on Tuesday. And what I've done is produced a short video, as short as I can make it. Remember that you can speed this up in YouTube. This will be posted on YouTube. And I found that I can listen to up to 2 times as fast as a speaker speaks. I can listen to that about twice as fast many times, depending on how slowly the speaker is speaking. So you can try that out. You can try it at 1.25, 1.52, and you can probably get through this video relatively quickly. But you also have the ability to go back and understand it a little bit more by playing things back that I've said that you might have missed. To start this out, let's keep in mind the motivation here. Here we have our lonely little unicorn and the 3 different dimensions that we can manage when we're delivering to a customer. This is just one model I've brought into the course that I like to use. It's commonly referred to in a casual way in industry is how do we deliver good, fast, and cheap to the customer, or we should say good, fast, and cheaply to the customer. Okay, so this is a supplement to help understand the learning curve in terms of this. How do we work with these conflicts and deliver to the customer so we get good customer satisfaction and good reputation score as you're learning in McGraw-Hill practice. Okay, so this is a supplement to the reading that you were to do in Chapter 6, the homeworks that have been assigned, and the lectures that I've already done on this topic. Okay, so to talk a little bit about our lonely unicorn here, who doesn't exist, the way that we describe this is nearly an impossible situation. It's very difficult. Be careful promising everything to a customer. And the learning curve has to do with this in the fact that if you have not done something before and you talk to a customer and you get excited and you see money and you want to take the contract, just remember that if you haven't done it before or you have new employees coming in, that there's some training involved with that. And your learning curve is a sincere and distinct impediment to launching out of the gate at 100 miles an hour. Okay, so you're going to have to factor into your scheduling that it takes a while both as an individual in your organization and as the organization itself. As you've read in Chapter 6, there's aspects of both individual learning and organizational learning. Okay, and just to remind us, what does this have to do with anything? Okay, here's these 3 dimensions a customer is always pounding the table for. Okay, they want good, as in quality. They want it now, and they don't want to pay anything for it. That's half of business right there. Understanding that we have to manage within the customer expectations and demands here, that if they should want something in very high quality and they'd like to have it fast, then usually the cost goes up. In other words, they're not going to get it for cheap or a little amount of money. If they want it fast and they don't want to spend a lot of money on it, then we might have to bring back our quality standards on that. And sometimes the way that that can happen is we might be cutting out testing. They might be willing to take more failures along the line that might come out of rushing an order than they normally would, and you'd have to factor that in. So this little unicorn here is your friend. It actually comes to play whenever you're sitting at a table doing contracting. Okay, so let's just do a quick review of learning curves. Done this a couple times already. Learning curve theory based on 3 assumptions. The amount of time required to complete a given task goes down. Okay, listen carefully. Also, we can model the cost per unit. Okay, we use the exact same model here that shows the time per unit decreasing. We can also show that the cost decreases along the same curve. Got that? I mean, there's 2 different applications for this. One of it is how much time it's going to take that we can promise the customer, and the other is how much we can offer them as far as pricing goes. Okay, the second underlying truth that always exists, the unit time will decrease at a decreasing rate. Okay, so can you explain that? All right, you know that there's this curve. It's a geometric curve. It's not linear, and we start with some amount of time to begin with that's high, let's say 100 hours, and it decreases by some amount each period or for each unit, from the first to the second unit, from the second to the third unit, third to the fourth. The time it takes is decreasing, but each time it decreases, it's decreasing by a little bit less. And that's why it smooths out to a flat curve after a while. Be ready to understand so far all the points that we've made here, these 2 points. And thirdly, the reduction in time will follow a predictable pattern. Okay, that's great. That's why we're studying it. If it was unpredictable, it wouldn't be worth studying. Be a quick footnote, and that would be it. Okay, so page down here. Learning curves. Let's try this. As the key common observation of production times is this: there's a predictable trend in how long it takes to perform an operation. Okay, so I'm saying this in a little bit different way. And these are common observations across industries for different tasks, different products. And we're learning the core to this, the very basics from which we can judge other real situations, actual situations. The pattern observed is relationship between the time it takes to produce n units and the time it takes to produce twice that number of units. Every time it doubles, there's a constant factor involved. Every time you double the number of units you've built, the time it takes goes down by a predictable amount, and that's our learning curve, okay? As we count the number of units made, the number of repetitive operations in a service, let's say we're talking products first, service second, it applies both places. Every time the number of units produced doubles, the decrease in time it takes is a constant called, it's a constant factor called a learning curve. The number is expressed as a percentage, and we've talked about this. In general, we talk about learning curves within the range of 70 to 95%. So if we build n amount of units and it takes a amount of time, then to build twice that amount of time, it takes the learning rate. You need to multiply the number of units by the learning rate, and you can figure out how much time it's going to take for that individual unit out there at twice the count. If we build 1 unit of something, it takes 100 hours. Now here we're going to use some real numbers. This is to explain the previous page here, okay? If we build a unit of whatever it is, and it takes 100 hours to build it, we build a second unit, we just doubled the production volume. We went from 1 to 2, okay? That's our factor we're looking for. We're looking for every time we double the number of units, so 1 to 2. And so the second unit takes 80 hours. The first one took 100, the second took 80. Then the way that we calculate our learning curve is the amount of time for the second versus the first is 80 over 100 is 80% learning rate. Immediately we should be thinking that we want to see if it holds up, and we look at the fourth unit. Because we have 2 units now, we need to double that number again before we experience the learning rate, the effect of the learning rate. So at 4 units, the fourth unit should be 80% of the second unit, or 80% of 80 is 64 hours. That's what I explained down here, okay? So far so good. It should be straightforward here. Everything's good so far. It doesn't get too much more complicated than this. Let's look at a table that shows the units produced, okay? So which unit we're building, the time it takes to build each unit. Then we're going to look at the cumulative time. We're going to keep track of elapsed time as we do the first and the second. We're going to add their times together so we know how much time it took to do 2 of them. Okay, and then finally we want to take a look at the average time it took to make each unit, because that could be very important for forecasting. Okay, so I start with an example straight out of the book. I think if I page over, I may be sitting on it right here. Okay, so this is the book. This is the online version of the book. We're going to get down to this in a second here. But this table that I've just reproduced is Exhibit 6.2 right in the book. We'll come back over to PowerPoint. Okay, and here we're using 100,000 hours as the first unit of something. Okay, and when we produce the second one and we measure how long it takes, it took 80 hours, or 80,000 hours rather. You know, these are like nuclear reactors or something. Okay, and when we go from 2 units to 4 units, we should experience this 80% learning curve, because we figured out it was 80 by taking the second unit's time 80,000 over 100,000. That's 0.8. And just as I described before, we're just seeing it in a table now. We double the number of units, multiply by the 0.8, and you get 64,000 hours for the fourth unit. Okay? Now our other column I told you we were going to look at is, let's keep track of how much time it took to do all of these. So the first one was 100,000 hours. The second one's 80. If you add those together, it took us 180,000 hours to do the first 2. And if we go over to the last column here, we could see that the first one, when we're looking at averages, it's silly, but you know, the average of one is itself, and so 100,000 hours is the first average that we get. And if we look at the average time it took to do 2 units, it would be the combined 180,000 hours over 2 is 90. Okay, so these are numbers that you really want to keep track of over time and manage to measure and adjust to. Okay, here's a little bit something interesting I need you to take a look at here. Okay, this table is conveniently set up so that every row is the doubling of the number of units before it. What they're not showing here is between 2 and 4 we had to build number 3. between 4 and 8, we had to build 5, 6, 7. Okay, so they've selected out of a bigger table certain points we're interested in, of course, every time we double the number of output units here. Okay, from 8 to 16, 16, 32, etc., etc., etc. Okay, so for each of these instances, what they're showing us over here is a little bit of information between the lines, literally here. Okay, so let's take a look at what I mean by that. And that means when we went from 2 to 4 units, we measured that it was 64,000 hours it took for the fourth. And then we get this number that says the cumulative direct labor hours. So that means how long did it take us to build 1, 2, 3, and 4? And we can actually back out how long it took to do unit 3 out of this. Why? Because this 314,000 is the time it took 1, 2, 3, and 4 to build, and we have the individual numbers over here, 1, 2, and 4, and just subtract them out of there, and we're going to figure out how long it took to do item 3. Okay. However, when we get down here and there's 3 units left out, 3 information rows of units left out, we can't interpolate between there. I just wanted to point that out. Okay. Excuse me. Let's try another one. Now let's go to real world. We need to be really fluent with Excel here, so I'm going to flip over to Excel. And over here what I did was I created some data in a table, which here's my first table. I created a different table. Okay, let's say that something took the first unit 100 hours for us to build, 90 for the second, okay? And let's say it took 84.62 hours to do the third. And for the fourth unit, it took 81 hours. Okay, so we have the numbers that we have here. I want to pay attention now, because what we're looking at, all the rule says is that every time we double the number of units, we should experience the learning curve. And so when we go from 1 to 2, we should immediately see the initial learning curve. So it would be 90 hours over 100 hours, okay? And the learning curve, I'm going to put over here the learning rate, I'll type in. Okay, so we can put that in for number 2. And what do we know? We know we can go to 4, and we should be able to take the learning rate at 4 because we doubled the number of units. We can come over to 4, and let's calculate the learning rate there. That's going to equal the time it took here over the time it took back here at 2. And as we see, it's coming out as 90%. Okay, so 90%, 90%. Then when we go to 8, we need to double the number of units, and when we've doubled the number of units, we should see the learning rate take over again. It would be this number over that number, right? Let me just turn that on, okay? Put it all in the same format. Okay, so you see we went from 1 to 2, we can measure the learning rate. 2 to 4, we can measure the learning rate. From 4 to 8, we can. Okay, but let's be savvy too. When you have scarce data like this, we want to get at these learning rates and see what kind of variability there might be, because we also could measure, and I'm going to color these cells in here so we can tell what we're tracking. We color that with anything. Let's just color like that with light blue. Okay. Okay. What we can do is we can figure out what the learning rate is between production of item 3 and item 6, because we doubled the number of units here. Suppose we forgot to take a reading, or we got bad results, our equipment wasn't working, and our timer was bad, and we failed to pick up between 1 and 2 what the learning rate was. Well, if we didn't get 1 and 2, the readings for 1 and 2, we could start with 3, and we can back out of this some information, because what we need to do now is just watch till we get to number 6. Okay, so suppose these numbers didn't get taken and the equipment was messed up. This happens all the time. It's actually a real situation. Okay, what we can do is just check the learning rate from 3 to 4. So let's do that. So I'll plug in equals. We need the time for the 6th unit being built over the time it took to do the 3rd unit, and I hit enter there, and lo and behold, it's 90% again. Okay, so our expectations are working, that every time we double the number of units that we experience this learning curve. Okay, so then we could take from 4, we can take, suppose our equipment's now working correctly, we take the time that took to do the 4th to the 8th, okay, and we can calculate that, which we just did. I already done that, right? Okay. So what we were presented with in the book are 2 tables here that I want to go over, and these are more generic tables, okay? So if you're working in industry on the plant floor, you can use a table like this that shows us cross-section for every interval of 5% learning curve, okay, 60 through 95% learning curve on here, okay. These now become factors. We can use these to make calculations. What these are normalized to 1, okay, so these are basically factors we can use when we want to know how long it's going to take to do some number of units, okay. So if we produce 1 unit, what we want to do is remember how long it took us, okay? And we create our own table on the side, okay? So we start recording our first unit, let's say, took 10 hours. We'll try to use some numbers here, 10 hours. Let me move this just a little bit out of the way, okay? First one took 10 hours, right? And if we were told that we should be experiencing an 85% learning curve, I'm picking this totally random right now, we should be able to predict that the second one would be, number 2, would be equal to what we read out of this chart as 0.85. It's a factor we're going to use, okay? So that is equal to 0.85 times the amount of time it took to do the first one, which was 10 hours. So it would take 8.5 hours. Now, we've been using convenient numbers here, so I don't want you to get too comfortable with that because these aren't the way that they're going to roll in. Let's just say it took us 17 hours to do the first item. Then if we look at the same chart here at 85%, 0.85, the way we're going to figure out how long we think it's going to take the second item is we're going to use our learning rate and multiply that by the actual number of hours it took to do the first unit. So that's why I used an off-the-grid number here. Everything's a little bit too easy for us when we're using round numbers like 10, but if you're given a number like it took 123.62 hours or, 13.97 weeks, and we're doing it in weeks and whatever, what you do, once you're given the amount of time it took for the first unit, we're gonna find out that this is sort of the royal sword in the stone because we can figure everything else out from that. And let me paint that in gold there. Okay, so that's sort of the golden or orange calf that we have here. Okay, the first unit is going to tell us a whole lot more when we know what the learning rate is. Okay, so that's how we use this table. Okay, let's see. So at 60, if it was a 60% learning rate, okay, and it took 17 hours, we're going to do it differently over here. We're going to put 17 in here again. Okay, but instead we're going to say there was a 60% learning curve. So what you do is you multiply by the time it took for the first unit, and you get to, I have to put the equal sign in, that always helps. Okay, and that is equal to 10.2 hours. Now let's make sure we understand something here, okay? So this was at 85%, and this was at 60% learning curves, okay? These two columns here, right? And so we can compare. We would have two factories that are performing the same function a little bit differently, and their learning curve, maybe they have they did a better job hiring. This happens all the time. This is what you're looking at when you're trying to hire. You're trying to figure out the learning curve who you should hire. Okay, so that's this table, and the way that this has been figured out, it's been calculated. Before that other table that we looked at, we only had one: the first unit, the second unit, the fourth unit, the eighth unit. In here, we see those numbers that are interpolated between the second and fourth unit. So again, going over to the chart here, to get your third unit built would be at an 85% learning rate, 85% over here. To figure out how long it would take to do the third unit, you would take 0.7729. Now notice that they're using 4 decimal places here. You want to continue doing that so you don't lose precision here in your calculators. 0.7729 times 17 would give you how long it takes to do at 85% learning curve. We want to know the third unit. So actually what we're going to do is move this slightly downward. I'm going to come down here, and remember, we're going to calculate this for the third unit. And that's going to equal 0.7729 times, how much time did it take us to do the first unit? 17. And we get 13.1393. Okay, so the third one took 13 hours. Okay, that's how we use this table. Well, then we're going to ask ourselves, how did we get this table? Well, over here is the equation that is used to calculate that. It's called Wright's formula, W-R-I-G-H-T''S. This is Wright's formula for calculating the learning curve. There are other models out there, but we're learning one here to judge other outcomes by. I mean, we can learn other learning curves. Other factors might come to play, but this is the basics. We're learning the real basic here. This is Wright's. It's been around since the 1930s. Okay. All right. And what is this telling us? Y is going to be an amount of time. That's as in when we were just looking at the amount of time it took to do the third unit, is going to equal this big K is going to be the time it took to do your first unit, which I picked a random number as 17. It doesn't have to be 17. We could be using 17.89 or 98. This number K is whatever it took you to do the first unit, times X is your index. Okay, so in our case it would be the third unit build. So we've got 3 raised to n. Okay, 3 raised to n. Now what is n? N's a little complex. That's why we expressed it as a simpler thing. We're going to come into the book here. Again, I can't increase the size of my screen any better, but here's the equation in the book, y sub x. So y, the time it takes to do the third item, so y sub 3, is equal to the time it took to do it originally, 17 and something, times 3 raised to n, where n is equal to this slightly ugly thing down here called, or calculated as, the log of your learning rate over the log of 2. So you have to go backwards and get your learning rate, take the log of it, divide by the log of 2, and then raise 3 to that number. Follow me closely. It's really good to do some practice on this and understand how we come about the answers, because that equation is used in calculating the numbers here. And obviously, whenever we see something like this, that's a given in industry, it's an industry standard. I always say we're standing on the shoulders of the mathematical giants who went before us, because they've solved it out and said, you know what, this is a dependable equation in industry. If you're making financial forecasts and schedule forecasts, go with it. Okay, so all the reduction of the math has come down to this. All that, what does that mean? Well, at some part of the day, it becomes plug and chug. Okay, and so what we need to know is just recognize what I just said. What are each of these parts? Be able to calculate the log of a number on your calculator, okay, and write it down, and then be able to do the log of 2, and then divide that log of the learning rate, divide that by the log of 2, okay. So if someone were really kind, what they would do is they'd create a chart for us here, okay, and what I've put in here is a little grid that says the log of 2 is equal to 0.3010. That's kind of interesting. That's the number of our course. I just noticed that. There must be some kind of meaning behind that. And then I put down the log that we're going to need for the different learning rates here of 95%, 90, 85, 80, 75, 70, 65. These are the numbers across the top here, okay? So this equation was used, we punched in the numbers to fill this table up. Like we could actually create an Excel table that would include that. Okay, so let's just prove the sanity of all this. Let's just try to use the formula here to calculate the number that we used that is 0.779. So we went to 85% in the table over here, and we looked at the third unit, and we knew to multiply the time it took to do the first unit by 0.7729, okay? So I'm going to do a fresh calculation over here, although I do have some things in the margin. So over here, we're going to want to use our equation instead and see if it comes out to 0.7729. Okay? So if we do that, I am going to be kind to myself here and put in a learning curve. I'm going to punch in some constants here. So our learning curve is 0.85. Okay? Our index is going to be 3. We want the third number. And the original time that we wanted to know, the first unit took 17 hours, and let's just use the 17. Okay, so now I want to calculate using this. We have everything we need to know over here to figure out how much time it took to do the third unit. Okay, so to do that, that is going to equal the amount of time it took to do the first unit, was this. And we're going to multiply by a fairly large function. So I normally put my parens in first. Okay, so we're going to be multiplying by a fairly large function, which is going to be the nth unit is 3. We need 3 raised to something over something. Okay, so I always get my parens in early so I don't make a mistake, or I try not to make a mistake, and I believe we have the right amount of parens, but we'll find out when we hit enter here. Okay, so the numerator was the log. I have to put in equals. Okay, so the log of, I need a paren for that. There's a set of parens for that. And we need the log of our learning curve. That's our learning curve. And when you do the log, you have to tell it what base you're using. So it's base 10, okay, over the log of 2, okay. So that messy equation is B31 is your y, is your k. So B31 is your k, is the amount of time it took to do the first unit. And what it told us up here in the equation to do is multiply by 3 raised to the fancy n. And there's B30 should be our 3, that's our index, raised to the log of our learning factor, which is B29 is 85, base 10 over the log of 2. Okay, so if I have all the right parens in here and I hit enter, you should see the answer. Okay, something didn't work in there. We have to take a look up here. B31, and I forgot to put in the multiplier sign. Okay, there we go. Okay, that's all it was. All right, so the time that it took for us to do this, that we just calculated, if I go back up here, we had changed this number, but if I put this back as 17, we should see that we use the table in one instance to calculate it, and we use the equation in another instance to calculate the same things. Okay, so if I colorize the two cells to know that we're coming together on them, these two cells far apart here are what we were after. We got the same answer. We proved it out to ourselves. So at least we came up with the right numbers. They're very close to each other. There's a little bit of rounding errors that are going on here, and that's why they're just off by just a little bit. But remember, we wanted to get the 0.7729 here, okay? If you look at our equation, the 0.7729 is x to the n, okay? So let's just independently calculate this equation that we have here, okay? I'm going to take this text. There's two different ways you can copy these things. I'm going to put the text in here, okay? What we're going to do is I want to take a few things away. So I'm going to take off the time it took to do the first unit, which had a paren in it, so we have to get rid of that. And when I hit equals, now what I'm calculating in here is I took the k out of there, and we're calculating 3 raised to the n, and that's the number that we used. Here are the actual numbers that we used. So here was our learning rate. Here was our unit, our index, we'll call it. That was which unit we wanted. And this was k, basically. Okay, so that was k. That was the start time it took. All right, and all we did here when we calculated this was calculated the x to the n. X to the n is what's inside this table. This is how this is calculated. Someone did this for us. Actually, it's pretty easy. Do a computer, spit it right out, okay, automatically. All right, and what was our number? 0.7729, and it came out, yes, without any rounding errors on that one, okay? So that's how you use the equation. If you pick it apart, simply go through it, it will be what we call plug and chug or plug and play, if you will. So to summarize, remember the table that we're using here is Exhibit 6.4 out of the book. If we flip over to the book here, here's Exhibit 6.4 right in the book. What page is it? Page 133 in the book. Okay, so we have a more complete table in here that shows us if we want to know if how much time it took to do the 60th unit at 85%. We would just take 0.3829 and multiply it by whatever the time it took to do the first unit. So this is how to get these individual units, but as you can see, the table isn't complete. There's a lot of space missing, 70 to 80. If we wanted to know how long it took us to do the 73rd, 74th, you'd have to use the equation. Okay, so you'll probably be asked to do it both ways. I'll probably ask you an easy one that comes off the table, and then I'll say, oh, if we've got 20 here, how long would it take us to do the 21st, which makes you have to go use the equation, okay? Gives you that comfort that you're going to have to use the equation to calculate it out. Your index would then become 21. You'd leave 0.85 as your learning rate, okay? And off you go with your calculator, and you could use the log tables that I created here to help you out, at least figure the log of the learning curve over log of 2. Okay. All right. So now let's go look at exhibit, I believe they call it exhibit 6.5. Okay. So let's learn how to use this table here. This is equally interesting. Okay. All right. How does this thing work? Okay. Whereas we're showing the times it takes for individual nth units. Okay. So if you remember the first column here, I can't show it all at once. The first column was 60% right here. It's 60% learning curve. Think about this. Is 60% better learning curve than 85 or worse than 85? Be sure you can answer that question. Okay. So this will tell us at a 60% learning curve, the 200th unit will take 2% or 0.0201, 2% of how long it took to do the first one at 60%. That's a very aggressive, 60 is a very aggressive learning curve. Okay. Another way we can look at it is Exhibit 6.5. So follow us on this here. Okay, so it kind of looks like the same kind of table. We have our learning curves across the top. All right, but what the difference here is, this is the cumulative time. Notice the heading here says cumulative. It says if you want to know how long it takes to do 2 units, i.e. the first and the second, take the time that it takes for the first unit and multiply by 1.6. Okay, and that will give you the total time it takes to do 2 units. If you want to know how long it's going to do 12 units in a row, take 4.144 times the time it took to do that first unit. Now remember I was saying, and I put it up here, that the first unit, I put it in orange here, okay? Well, these first units, the times it takes to do the first units gets used over and over again, okay? So you always want to know how long did it take to do the first one, and then when you have these multipliers, if the first one took you 10 hours and you have a 60% learning curve, to do 2 of them is going to take you 1.6 times 10 hours is 16 hours. 10 for the first, 6 for the other, all right? Okay? Okay? If you want to know how long it takes to do 20 of them, it would be 5.17 times 10 hours, or 50 hours there. 51 hours. Okay, it'd be 51 hours to do 20 units. Okay, so suppose you do a pilot program, and to figure out your learning curve and get things under control before you go to a client, to a customer, let's say you run 10 units before you even sell any, and then you tell the company, you know what, we'll ship you 90 more. Okay, we want to ship you 90 more, or the first 90 for the customers. Now what you need to do is you've had the benefit of 10 pre-flight units that you put out, right? And let's say the first unit took you 10 hours, okay? So to do the first 10, it took 3.813 times 10 hours. That's 38 hours. It took 38 hours to do the first 10, okay? And then when we come back down here, we can see now we were going to do 90 more. This is a total of 90. Now you can't come in, pay close attention, can't come into this chart and just grab 9.191 here and multiply it by 10 and get the amount of time it's going to take to do the subsequent 90. Understand? So you did 10 first, you had the benefit of learning, but you're going to sell the second 90. So how would you do that? Well, the numbers work out that on our table, we can look up, well, by the time we get done with the first 10 and then the 90, we're going to have done 100 units. So we would multiply the first number that would took us 10 hours by 9.539. That's 95 hours. It would take us 95 hours to do 100, and then subtract the time it took to do the first 10. That's how you get the subsequent 90. That's a very common problem. Let me say that again. It's a very common problem, is when you want to know, after you've done a pilot program where you don't deliver to the customer but you get the wrinkles ironed out, the next 90 would take you to the 100th unit, okay? And so you just subtract the time it took to do the total 100 from the time it took to do the first 10. And I think you have a homework problem like that, okay? So we're pretty much getting to that point of completion of anything you really need to know on here. I've showed you around a little bit how to calculate some of the learning curves here, okay? And the reason why these learning curves came out so nice and even, if I dare show you, is that to interpolate between the known doubling of the factors in our table over here, we went from 1 to 2 to 3 to 4 to 5. I actually used the y equation in here. You can see where I actually put in the y sub x, Wright's formula. I actually used Wright's formula in my data here. I actually pre-calculated it, so they came out extremely smooth and even, okay? Normally when you take these readings, you're going to have variance. You're going to have a little, each of these numbers is going to be not directly on a 90% learning curve line. It's going to be a little bit off. So when you do your readings, it's going to be 91% here, 89% here. It might get a little bit strange and get 85% or 95%. But overall, you're going to have a 90% observable learning rate, okay? So let's see. I think that covers any intro, covers the topic pretty well in 30 minutes. If you put that on speed up, it's not going to take, I guess it's 37 minutes. I guess it won't take that much time to listen to it if you speed it up and then go back to listen to the parts that you missed. Problems 6.1 through 6.3 for homeworks should be pretty straightforward from what you've heard already. But let's take a look through what we need to do for problem 6.4. It says, you've just completed a pilot run of 10 units of a major product and found the processing time for each unit was as follows. Okay, so immediately you should be thinking of, we're going to figure out what the learning curve in this is, right? Okay, if we go over to the book, let's flip over the book really quickly here and take a look at what the rest of the problem asks us here. And I've been logged out, so please stand by. I can't predict that, so we have to live with it. Usually it brings me right back to where I was. Okay, so we should be back on the same page we were just on. Okay, all the tables, everything that we have here. All looks good. Let's flip back to the question sets. Okay, as I go back there, do be aware of there's an individual learning curve that we understand. Some of the factors definitely understand. I've mentioned before, it's very important in hiring. Bring this to the forefront. When you write a job definition, you should be able to have a candidate perhaps take a test at something they're going to be doing and just watch to see what their learning curve is. You could possibly do that. Proper selection of workers, you could add that. There's strategic reasons for using this. Proper training. When somebody comes in or you're starting a new project and the group doesn't know individually, they don't know how to do something, you have to have training. I mean, you can't expect to have fireworks when everything's the powder's wet, so to speak. You have to get people active and trained up. Motivation, okay, hey, that's up to you, how good of a manager, what style you're going to use. Work specialization. If people are switching job definitions, then the learning curve can be quite long. Do one or very few jobs at a time. Okay, it's great. Focus on one thing. Multitasking is a myth. Really, unless you've become an expert. And if you leave something, it's like learning a language. If you leave speaking the language and you come back to it after a while, you'll find that you've forgotten a lot about it. All right, so there's even that. There's a relearning curve. Okay, using tools and equipment that assists or supports. Okay, so that could actually accelerate your curve when you bring in a new machine that works faster. Obviously, those can't be accommodated in human learning. If you bring in a new system, perhaps someone has to be retrained again. So that could slow you down as well as speed you up. Think about the offset there. Provide quick and easy access for help. Okay, so don't let anybody sit there languishing in trouble on a plant floor or at their desk processing forms or getting in a line or having a line come at you in a service industry with a difficult customer that they don't know how to handle. Okay, there's actually specific training on how to handle difficult customers on that. If you look it up on the internet, there's people that train only in that area. Everything goes well until it doesn't, and then how do you train your employees to process through somebody gracefully so they don't take your whole operation out as a bad, unhappy customer? Okay, and allow workers to help redesign their tasks. That's huge. A lot of this came out of the auto industry. They speak about the aircraft industry for sure. A lot more dependability necessary on the outcomes of the aircraft. Planes have gone down because somebody was careless and didn't write the right numbers in, et cetera, et cetera, et cetera. Okay, so we'll make sure you're aware of these. These are really important and really great area on a test question for a narrative as to thinking. Organizational learning. Okay, you can read about that. Make sure you understand that. But let's go back to the problem here. Okay, so here we are on the digital side of the book toward the end. Solve problems. A job applicant is being tested. Make sure you go through the solve problems all the time, every chapter. Okay, there's a lot to be learned here and probably some good things to call out for an exam possibly. Okay, solve problem 2. They take you through something to calculate what the learning curve is and then some forward-thinking questions here that make you think about it a little bit more. Okay, so the average cost of the first 1,000 units can be estimated using Exhibit 6.5, which we just went over. The cumulative improvement factor for the 1,000th unit at 80% learning is this. Remember, we're in cumulative world. Okay, so it's going to show you how long it takes to do everything up to and including that number in the table. Okay, so it says 158. Okay, the cost to produce the first. Now, in this question, they're going to ask you about cost. Go back to what I said earlier. Mark this. You just apply it identically to cost reduction as you do to labor reduction. Okay, same thing. Okay, there's some pretty good discussion questions here. Objective questions. Okay, so 1, 2, and 3 were part of homework, I believe, and I think we're looking at 4, 5, and 6 as the ones that I want to go over. What I wanted to do was get at what are the actual questions here. So question 4, we see this table. They give us the unit time it took for each one of these. Okay, and so according to the pilot run, what would you expect the learning rate to be? You can do that now based on the learning rate. How much time would it take for the next 190 units? That's a curious number. Something I might have just talked about where we don't have the number for 190 in there. We have the number for 200 and we have the number for 10, and we have to take the difference. Okay, because if you read this, this is like a pilot run. It just said a pilot run right up here. That means it's internal, okay? It's like you're not sending these out to the field, so you've got the benefit exactly why you did it for 10 units, and you're going to build 190. Perhaps you want to look in the table at the 200th unit, because that's where you're going to end up, okay? And how much time would it take to make the 1,000th unit? Okay, so we were on the cumulative curve here. That's interesting. For B, we were using Exhibit 6.5, but probably in C, you're going to want to look at 6.4, okay? All right, so question 5, Jack Simpson, contract for Nebula airframe, bidding, gathering cost data. He had 3 units. He found the first unit in the third. Okay, so he has a time it took for all 3 units. In a contract for 3 more units, how many labor hours should Simpson plan for? Okay, and stand by. I need to get an insight on. Okay, I'm back. And just to affirm that for 5, I just wanted to check for this. For problem 5 here, you want to tell how much time it took to do the 4th, 5th, and 6th units. Just wanted to check the wording on that. In a contract for 3 more units, how many, it actually should be like how many more labor hours should Simpson plan for to do the 3 and the 4 and the 5th. Okay, so just the time for 3, 4th, and 5th, not 1, 2, and 3. Okay, and the last problem here that you have, Laser Technologies LTI, they had a pilot run of 20 high-powered lasers. Kind of grim here. They could destroy stuff with it. The 20 units have been produced, funded in part in private research. Okay, so internal development within the R&D arm of LTI. They ate the cost of the first 20 units of developing that, so they could go out with confidence and pitch it to the Department of Defense. Okay, testing of the laser units has shown that they are effective defense weapons. And okay, so that's kind of a extra information. It's wonderful to know, but not anything we need to calculate. DoD has asked LTI to submit a bid for 100 units. They've already built 20. Okay, think about that subtraction approach that we took here. And they give us now, are they going to use cost? Based on the past experience, what is the learning rate? Excuse me. Now they're using cost in here. So they just flipped the application from hours to cost. It's the same thing. Okay, so calculated the same way. What bid should LTI submit for the total order of 100 units? Okay. But they've already built 20 of them. Okay. It's like a hint for where to look in the table. What is the cost expected for the last unit under the learning rate? Got it? Okay. So they just want the time for that 100th unit, just the single 100th unit. And with that, I think that's probably a good enough lead on all these problems for you. If you have particular problems, be specific, send them over to me. If you have a hard time submitting an answer through Connect, it's not taking it, you've got to watch your precision on that. And if you're really having trouble, you might want to double check with me, and I can check the answer to see how far off you are, if you're on the right track or not. Okay? I hope this helps. Really pay attention to this video. Do a good job on the homework. Solve problems. Make sure you understand them. Understand the soft side of learning curves. Actually, I say soft. Actually, the sharp side of learning curves. The soft side is really calculating them. You know, if you don't do anything with that information, it doesn't matter. The sharp side of learning curves is a strategy thing. Some of what I was talking about before in the world of hiring. You know, what does it mean for individuals as a learning curve? And then read up on what the learning curve for a corporation or an organization is all about. Some of the factors. Read between the lines there. Be ready to think. Be ready to think on the exam. Okay. I hope this helps, and I'll be publishing this up on YouTube and sending you a link very quickly. Bye now.